Welcome back. In this episode, we take our first steps into the late game, upgrading our wafer production with Naquadah, building the powerful assembly line, and unlocking the LuV Energy Hatch. This is Star Technology. Let's get into it. Something else that is probably worth looking at is this Naquadah-doped monocrystalline silicon ball. Back in EV, we unlocked the ability to have this phosphorus-doped monocrystalline silicon ball, and that's been the cornerstone of our wafers and basically all the chips that we make. This new Naquadah-doped one is quite interesting. It requires 16 blocks of silicon, some Naquadah ingots, some gallium arsenide dust, and 8 buckets of argon. Most of that is pretty simple. I mean, 16 blocks of silicon, that's a lot of silicon, but it's not hard to make. Naquadah ingots, we now have access to Naquadah dust. All we've got to do is run that through a blast furnace, which produces the hot Naquadah ingot, and then we can just cool it in the vacuum freezer. So it's nothing too fancy there. It's not even that slow. So that's doable. And that creates these Naquadah-doped monocrystalline silicon balls. So it's a slow process, but that's always been the case for these silicon balls. I did set up a passive process for the monocrystalline silicon balls for the phosphorus ones. What I would probably do is just convert this. If we look at the NAND memory wafer as an example, the phosphorus-doped wafer yields us one single NAND memory wafer. It takes 45 seconds. If we were to use a Naquadah-doped wafer, it takes 25 seconds and gives us 4. Unless I have missed something, getting the Naquadah-doped monocrystalline silicon balls makes the phosphorus one completely obsolete. So for that reason, I can convert this blast furnace over to just passive those. But they actually do yield quite a lot. In a cutter, you get 64 wafers, and each of those wafers produces 4 NAND memory things. So you don't need too many of these. This recipe here actually requires those HSSG coils. So this is only RTM, so I'll have to upgrade that. I'll also have to change over the input hatch here, like get rid of the nitrogen gas and tell it to import argon instead. The input stocking bus here that I set up, I'll do the same thing for this recipe here. I don't think I showed when I made this. I think it's just something I played around with. It was a bit tricky to get working, and then I kind of forgot about it. It's like an input bus, but it interfaces directly with the ME system, as you can see there. So there's no interface or anything between them. It's sort of like a bus and an interface in one. And it's also hard to set these up. It's a bit of a pain. So that's why I haven't used it elsewhere. And basically what this does is it just replaces the need to have 3 different ones. Well, first things first, we're going to need to replace these coils. So I happen to have some spare coils. Let's do that first. Oops. Like that. All right. That's taken care of. We're going to need to replace this. So we're actually going to go with this one instead. So that'll fire up because it's got all the ingredients there to keep going. I'm going to cancel those like that. Let it finish that and then go ahead. So can we drag that in? No. So this is the problem I had. It's actually a bit of a pain. I think you have to drag it in from here. No? I can't remember how I got it to work. Do you need the objects? There must be an easy way to do this, but I don't know what that is. You can't drag it into either of those slots. So I might just need to actually make some of those things. So I happen to have a block of silicon. I can make a Naquadah ingot if I don't already have one. There we go. And gallium arsenide dust. So I can do that. How do you set the amount? Oh, okay, it's behind there, but scroll wheel adjust number, okay. But it keeps resetting it to 0. Why is it resetting it to 0? 16 I need. Okay, that's a bit confusing. Oh, there we go. Okay, something was going wrong, but now I can use the mouse wheel to scroll that. Do the Naquadah ingot. Luckily, that's only 1. And then the gallium arsenide. That's not exactly what I want, is it? Because this is all crafted. And I want it to craft it on demand, but I can't put a crafting card in here. It doesn't have that option. So this stocking input bus, that's why I haven't used it elsewhere. The way I'm using it might be wrong. It's a little bit of a pain to set up and doesn't seem to be that much better. If I go to the requester over here and just set up to always have those in the system, if I do that, always have, say, 32 and craft 16 at a time, turn that on, that will now do that. If I do the same for Naquadah, say 32 of those, 16 of those, and then pull that out of there. So we want argon. And then we'll empty this. I think that's it. All right, well, it took a little while, but we have our first Naquadah doped monocrystalline silicon ball. So let's set up the cutting recipe for that. This requires the clean room, so we can't use our new cutter, but we can use that existing one that we do have. So let's set up a recipe for that. One of those, do that. Right, so just pop that in there. That one's kind of obsolete for the moment, but let's just make sure that it's working. Then we're gonna have to re-encode lots of recipes. Yeah, it's cutting. Excellent. So then I've got to go through and replace all of these. It's very exciting because making of the circuits is one of the slowest things. Like a lot of things you can parallelize and make faster, but making the circuits always seems to be slow. A better recipe for this is going to be amazing. So now that we have the Naquadah doped wafers, what I've done is I've re-encoded all of the wafer recipes. We also now have access to something interesting, which is something called an advanced SoC wafer. So we need to get a glass lens, and then we're going to be able to make these. So I think that's probably a good thing. We can probably make better circuits. What are they used for? We can make nanoprocessors. So the nanoprocessor yields 4 from that. And I think the recipe we have in here, we only get 2. Okay. So that increases the yield that we have for those. Well, that's kind of handy to have. Okay, so I've made that glass lens, and I've also encoded the pattern, and I've got the input bus ready, so let's get this installed. Take this out, and then pop this in. Put a pattern provider on there, drop the glass lens in, and then hook it up. Just need to drop this recipe in here, so I should be able to request one of those circuits. That was pretty quick. Okay, so I'll grab that. That should tick off that. And then I just need to craft one of these. So I've already set up the recipe for this in the cutter. Done. If I grab that, quest completed. Now I can tick all these off. So having those new chips is great and all, but unless we're using them, there's no point. So what I've done is I have encoded the new recipe here, which replaces this one. So as you can see, we're going from only producing 2 nanoprocessors to 4. It uses some slightly different components, like the original one's got a nano CPU chip and a bunch of advanced SMDs. This one just uses the ASSC, so that's pretty cool. So I'll drop that in there and we can pull that one out. And while doing that, I also realized that I've been missing out on another upgrade I could do, which is this one. So the microprocessors, which are the MV tier chip, there's actually a better recipe using the system on a chip, which I had forgotten about. So I can drop that in and replace that. So we've got upgrades all across the board, which is great. So I should order one of those up, shouldn't I? So what was it? Microprocessor. That one? Wow, that was quick. So there's this thing called the Large Assembling Factory, and it's a multi-block version of the assembler. This one we've unlocked as part of the magical alloys along here, made from Stellite 100. And the recipe looks like this. IV robot arms, IV circuits, IV conveyor modules. There's an elite assembler in the middle, a few cables, and that's basically it. So it's pretty easy to make. Multi-block itself looks like this. It's quite wide. It's an odd profile, shape-wise. A bit more interesting than to say, one of these 3x3 blocks that we're used to. So it's got large-scale assembler casings, which we're already familiar with, tempered glass, and all the other usual things, like maintenance hatches and stuff. We should probably build one of these. The reason why I want to build this is to solve a small problem that I have, which is this. So if I go into the extended pattern access terminal and look for things that are called assembler, ignoring all the molecular assemblers, so we've got advanced assembler 3s, of which there are 5. We've got 3 elite assemblers, and an advanced assembler. So what's that? 9 different assemblers I have throughout my factory. Now the reason for that is we have a lot of different program circuits in play and a lot of recipes that we need to do. So a few of them are actually full. I did a quick run around and have a look at what I've got, and I've got like 6 different program circuits in play. Like I've got the no program circuit, I've got 6, 4, 8, and 1, and 0. What I hope to do is build one of these large assembling factories and then put a whole bunch of buses on it and simplify what I've got set up. So, I mean, that's the plan. I was thinking over here might be a good spot for it. I'll grab the components and get to it. Gathered all the components, so let's build this thing. Start with the energy hatches. Rotate them into place. Put down some of these large-scale assembler casings. Okay. It's a little bit of glass on the front here, then like a bit of a gap. Controller block goes there. Auto maintenance hatch, elite control hatch. So then I think we kind of just go around like this. A little bit more glass. Fill around like this. And then I think it's just a matter of finishing this bit off here. No, what have I missed? That looks correct. I'll have to figure this out offline and come back, I think. So with a little bit of fiddling around, I figured it out. It only can accept 1 energy hatch. Where I had 2 here originally, I had to swap one out. So what I've done is I've put in a 4 amp energy hatch instead. So that is actually running at LuV, but the recipe tier is IV. I think it's probably a similar situation as the circuit assembler. Now, we're going to need a lot of input buses on this. Now, this is actually going to be kind of tricky to set up. So I might do this offline because there's going to be a lot of combinations of hatches and buses and things I'm going to have to put in here. Say, for example, this one here. Some of these have liquids in them, which makes it a little bit of a challenge. I'll see what I can figure out. But yeah, I'll do that offline because I think it's going to be a bit of trial and error. So I'll do that and come back. Okay, so that was a little bit more complicated than I thought. There's a lot of nuance with all the different assembler recipes I have. I've only set up no circuit 1, 4, 6, and 8 at the moment, and not all of these are populated fully, so some of them are pretty busy. What I've done is I've only brought across things that don't require a liquid. Over time, I've just got to bring some of the more of the recipes over and sort out the fluid issue. I think what I'll probably do is just use a quadruple input hatch and just have it stocked with the fluids that it's going to need, because there's not going to be too many different fluids. So for example, with these, it's going to be liquid polyethylene. With the others, it's going to be like styrene, butadiene, rubber. So I can probably just get away with having it in there and just remove it from the recipes. But anyway, that is the large assembling factory. So we should probably move on. What's next? Maybe these chips here. We've done enough chip upgrades for the moment. Let's not do that. We're going to need this LuV Energy Hatch, aren't we? So there's a bit of a story behind that. So this is the recipe for the LuV Energy Hatch. Now, this is not an assembler. This is an assembly line. This is a different machine entirely. We've just hit a totally new concept. This has 16 input slots, multiple liquids at the same time, and something called a data stick that's required. So this is actually totally new to us. Each of these components isn't too difficult except for this Ludicrous voltage coil. The data stick is easy enough to make. I already have a recipe set up for that because I saw that we were going to need it. Okay, so the assembly line is an unusual machine because it doesn't have the recipes stored within it. Now, what I mean by that is if you provide the right ingredients to an assembler, it makes the thing that it needs to. Over here, there's a processing pattern for an SMD transistor. So if I was to put 1 piece of gallium foil, 8 fine tantalum wire, and 0.144 buckets of liquid polyethylene into this machine here, it would automatically start. That's all. Like, it knows the recipes inherently. The assembly line is a different kind of a machine. You have to provide it with a data stick that contains the instructions, basically. That's probably the easiest way to think about it. And so in order to be able to craft this, there's a few things we have to do. We have to build the assembly line, which is like a large multi-block, which I'll get to later. We have to provide all of the ingredients, and we have to provide a data stick. And the data stick isn't consumed. It's just basically the recipe for it. And so what we can probably do is just set up a large hatch that has a bunch of data sticks in it. Now, I guess the next question is, how do you get a data stick? So there's a machine called a scanner. So it's not too hard. LuV circuits, IV emitter, IV machine hull, IV sensor, platinum cables. Pretty easy to make. But what you do is you provide it with some sort of ingredient, like in this case, an IV energy hatch and an empty data stick, and then it scans that and figures out how to make an LuV energy hatch. So even though this recipe here looks like it produces an LuV energy hatch, it's actually the data stick for one. A lot of things from here on will be made in the assembly line. So what does the assembly line look like? So it's made of solid machine casings, assembly line gratings, assembly line casings, laminated glass, assembly control casings, and a bunch of other stuff. It has a hatch for putting the data chips in. But what's notable about this is the length of the machine matters. So we can actually make it bigger, kind of like the distillation tower. If we keep extending it out, you can see that it just gets longer and longer. Number of blocks along here determines how many slots it has for manufacturing. For the LuV energy hatch, it requires 5 of these slots, as well as 2 of these hatches. It needs to be at least 5 units long to be able to handle this. And the recipes actually get quite advanced and go up to like 16 inputs. So that's something new we're going to have to deal with, particularly soon, because we can't build the energy hatch without it. So there's a few things I need to do there. I need to build the scanner. I need to scan that IV energy hatch to create the LuV energy hatch data stick, gather all the components, and go from there. Okay, well, first things first, we need to get that data stick. Here's the recipe for the data stick: plastic printed circuit board, CPU chips, NAND memory chips, RAM chips, fine red alloy wire, polyethylene sheet, and some liquid soldering alloy or tin. Here's something that I find a little bit odd. I haven't talked about this before, but I'm going to go on a little bit of a rant, I think. Why does liquid soldering alloy exist? Because this requires half the amount of this thing. But this is so much simpler. This is just tin. We've got loads of tin. Put it into a fluid solidifier. You've got liquid tin. You're done. That's it. Liquid soldering alloy is complicated. It requires lots of tin, lots of lead, lots of antimony. You have to make it in a mixer or some sort of thing. It doesn't seem like it's worth it. Why would you bother? If you required less of the other components, then it would make sense. Anyway, so basically I've just used tin. Why would you use the other one? Anyway, I've made a data stick. I've got that in my inventory here. I also have the Elite scanner. I've also got the energy hatch that we need to scan. So let's go install this and get that process going. Where's my IV stuff? I think it's over here. Yep. All right. So I'll just put that in there. And now we just put the data stick in there, I guess, and the energy hatch in there. There we go. Got the data stick. So that part was easy. So I think we just go all out, just build the whole thing. That way we don't have to upgrade it later. Solid machine casings, obviously we can make. Assembly line gratings we have already. Assembly line casing and the assembly control casings are the new ones. So assembly control casings look like this: IV robot arms, tungsten steel frames, steel, and Ruridit gears. So we don't have Ruridit yet. So how do we make Ruridit? It is made from a hot ingot, and the hot ingots are made from Ruridit dust, and Ruridit dust is just ruthenium and iridium. So I already encoded the recipe for that and set it all up, so that's why we can request Ruridit ingots. But I haven't yet set up the recipe for gears, so I'll do that in a moment. This is the one that is the complicated one, the assembly line casing. So these require 4 EV chips, an IV sensor, an IV emitter, IV electric motor, tungsten steel frame, and a HPIC chip. And that makes 2. And we're going to need, like about 16 or 17 of these. I will set up some recipes for both of these things and start manufacturing them and come back once I've got enough to build that full length assembly line. I've gathered all the components I'm going to need. Turned out to be quite a lot of different things. So something that I overlooked, which took a little bit of extra time, is the data access hatch. We need that to store the data sticks, and this is what the recipe looks like. So it's made in an assembler in the clean room that is EV. So basically I had to build a new piece of equipment in the clean room for that to work. But the actual ingredients aren't that complicated. It's just an EV input bus, data stick, some EV circuits, and some liquid polytetrafluoroethylene. So I made that, and everything's good. So this is how big it's going to be. So it looks like the energy hatches have to go at the top. Okay, well, that's just how we'll have to do it. Base layer of it seems to be all made of solid machine casings with an output at one end and an input at the other. So I guess we'll just do 2 lines of solid machine casings. Yeah, cool. And then another row here. We're actually going to need 16 input buses. They have to be ULV, by the way. So they have to be just single input. Rotate these into place. I think this one has to face this way. It seemed that way, but all the rest have to face down. Let's verify that that's been done correctly. Yep, it has. Excellent. Now we just need the output bus, like that. So that sort of makes sense. It kind of goes down the line and pops out the end there. So we've got, what are they? Assembly control casings and laminated glass. Do the laminated glass. And then the assembly control casings. And then more laminated glass. Then the controller block itself, which seems to go on the end here. Got the data hatch and then assembly line gratings and then on the back as well. So let's put the data hatch like that and then the assembly line gratings. So all through the middle there we have assembly line casings. Energy input hatch there and then just solid machine casings. So I guess we'll just do like this. IV1 for now. Aha! And it's done. If it is only one energy hatch, let's just test that. Can we put two to overclock it? I'm thinking no, but we'll give it a try, right? Oh, okay. Yep. Wonder if I could put them down there instead. No. Okay. That's what I thought. It's a little bit annoying. I don't like the energy hatches to be at the top. Okay, well, what we can do is that. Energy converter. Let's have it just sitting on top. Almost like it's part of the block, really. Now we just need a flux point. Set that up. And bypass limit. And that is good to go. Also, I've just realized I've forgotten a hatch for liquids. So I'm going to put a quadruple input hatch here. One thing that is kind of tricky about this assembly line, is that it does have these individual ULV input buses. And the idea is that each component is put into here in order. So in that recipe here, for the LuV Energy Hatch, that LuV machine hull needs to go into that first slot. The niobium titanium cable needs to go into the second slot, etc., etc. So this is where it gets a little bit tricky. I'm hoping that I can get it to work with an ingredient buffer. If I place that down there, the other thing I wanted to do was to see if this can be facing upwards. It can. Okay. Well, that makes life a little bit easier. So now I'll just run pipes, starting from this end over here. And then into there like that. Now that is not what I want. That looks ugly, so I'll disconnect that. Set this to extract. Put an upgrade in there so it's nice and quick. I can put my pattern provider and stuff on that. Do I have any patterns? No, I haven't encoded anything yet, but that's how that will work. And then the data access hatch is where the data stick goes. There we go. So I should encode that recipe. And then there's only one more thing to do, which is a little bit of a hiccup that I didn't anticipate. So we can't quite make that hatch yet, and I'll explain in a moment. That's got all the ingredients there. The data stick does not need to be part of it. That's the recipe, so we take that out. But everything else looks good. I think that should all be in the right order. And that is that. Hopefully. Guess we'll see. It's a whole brand new piece of technology. I'm pretty excited about it, actually. So that can go in there. So the problem that we have is this thing called the Ludicrous voltage coil, made from magnetic samarium, which samarium we already have. That's not too bad. It comes out of rare earth processing, and we have a fair bit of that, so that's fine. Osmiridium is not too hard to make. It's just another alloy in the alloy blast smelter. The problem is this thing here. This requires an LuV assembler. So unfortunately, we can't use our new assembler, this guy here, because it is only IV recipe tier. So we have to build an Elite 2 assembler. And that actually requires LuV parts. So we don't have the robot arms, the conveyor modules. I will just encode those and come back. Actually, I'm back because I just realized something. The recipe for the LuV robot arm is actually done in the assembly line. This could be our first thing that we build there. I didn't even realize that. What I'll do is I'll encode a few of these recipes. So as you can see, I do not have any of this HSS stuff. So I'll do that and come back. I've encoded all the recipes. There's a lot of different parts for that. There are lots of different HSS equipment like rings, rounds, rods, gears, all kinds of stuff. I was actually wrong before when I said that this machine always required a data stick. It turns out it's not true because the electric motor, electric piston, conveyor module, and robot arm are all made in the assembly line, but they don't require a data stick. Maybe I'll just test it out with just an electric motor to start with. See how this goes. Lots of stuff. Let's give it a go. Oh, there we go. It's working. Brilliant. That is pretty slow. And one thing I forgot is the output. I need to put a interface or something on here. Given what we know about this, I should be able to just rotate this into place, facing downwards, right? Yep, cool. All right, then we don't even have to have a hole. Let me just fix that up quickly. Right, that looks quite neat and tidy. Everything on that list now is craftable. So I think I might need to set up HSS passively because it's taking too long to make. Where is it even made? It's probably this over here. 85 seconds. Yikes. Yeah, okay, that would be it, wouldn't it? That'd be why everything takes so long. So 85 seconds, which would be making the molten HSS, but we do get an entire bucket out, so that's 9 ingots. So it's about 10 seconds per ingot. Not great. But pretty soon we'll be able to overclock this to ZPM, which is very exciting. I'll come back once the Elite 2 assembler has been built and that we can proceed with the LuV Energy Hatch. So I got the Elite Assembler 2 made. I think we're ready to start making these Ludicrous voltage coils, which means we can actually make an LuV Energy Hatch. So let's give it a go. Let's request that. Everything looks good. It's going to take a little while because obviously there's a lot of components that go into this. We're going to need a lot of these. One small issue I ran into just before, the recipe for the robot arms had the wrong number of chips, like nanoprocessor supercomputer and nanoprocessor assembly. So it stopped working. Oh, there we go. We have an LuV Energy Hatch. That is very cool. So we need to make a bunch more of those. I'll make a second one because that way we can overclock something. But that is a big step forward. I think by the time you officially make the Energy Hatch for the tier, you can claim to be in that tier. So yeah, definitely we are in LuV now. Got lots of stuff that we can upgrade now. Just go through the usual process. Just upgrade everything that we can. Start building new coils. So it looks like coming up soon is this fusion reactor. We need to scan a piece of wire. Indium, tin, barium, titanium, cuprate wire. And then, ooh boy, that's big. Lots of different parts there we've never touched before. Ooh, requires ZPM circuits. Double plutonium plate. Okay, yeah, we won't be building that right now. There's obviously a lot that we still need to do. As I was promising, I did create a passive process for the HSS ingots. They're essential to a lot of the stuff in this current tier. So I figured I could do that. And so upgrading these to LuV hatches, I think is probably a good start. But this is obviously a hive of activity. There's so much going on now. Wonder what our power's doing. So we're not actually going too far over, because this normally is 256 billion. And it's going down very slightly. We're going to have to start upgrading soon again, but especially once we start putting these bad boys into usage. That's awesome. I'll make a whole bunch more of those and come back and start doing some upgrades. Well, I think that's a good place to leave this episode. So we got those new wafers, the assembly factory and the assembly line. That was pretty cool. The ultimate goal was that LuV Energy Hatch, which is going to allow us to upgrade loads of things. So I'll do that between episodes. So we can probably start working towards that fusion reactor. That'll be the goal of the next few episodes, just trying to get the components ready for that. Yeah, just take care of yourselves. Reach out to a mate if you haven't spoken to him for a little while. You never know when they just want to hear from you. Thanks for watching, and cheers.